Hello and welcome back everybody to another episode of the Towards Data Science podcast, and a very special episode at that, because we'll be talking to Jan Leike, who is formerly at DeepMind and now is the head of OpenAI's AI alignment team, where he's leading a group of researchers working to make sure that some of the world's largest AI systems behave in a way that's safe and reflects human values. Now, Jan has a really interesting way of thinking about AI alignment research that prioritizes experimentation with live systems over more theoretical approaches. And we'll be talking about why he holds to that philosophy, what specific strategies he thinks are most promising for aligning powerful AI systems, and more generally, what challenges lie ahead for AI safety beyond the alignment problem. Now, it's a rare treat to be able to talk to somebody on the front lines of frontier AI research like this, and it was a fun conversation that I hope you'll enjoy as much as I did. So with that said, I'm going to step out of the way and let the episode begin. Hi, Jan. Thanks so much for joining me for the podcast.
Thanks, Jeremy. I'm very excited to be here.
I'm super excited to have you. You're the head of alignment at OpenAI. We just had to do a retake. I called you the head of safety at OpenAI. I don't know what I was thinking, but you are the head of alignment at OpenAI. Obviously a very interesting and rich role with all kinds of problems that you're tackling day to day. We're going to dive into a lot of those. But I want to start by just asking you a general kind of life stage and career progression question. I think a lot of people are going to be curious about this. How did you get into technical AI safety research and alignment research, and why did you orient yourself in that direction?
Oh gosh, I've been in the field for almost 10 years now. I kind of got into it back in like 2012, 2013, and basically by reading a lot of stuff online. So I read like a lot of Eliezer Yudkowsky's writing and other people's, and that convinced me that we should take the prospect of AGI seriously. We should really think about like long-term impacts of AI on society, and there's like real work to be done here, and currently there's not that many people doing it. I mean, that was also back in 2012, 2013. Right. And at the same time, I was like wrapping up a master's degree. I wasn't even doing any AI. I was doing software verification. AI, I was like, didn't know anything about it. And so I decided that this is something I wanted to do with my career. And so I switched field. I did a PhD in reinforcement learning.
I'm curious, like, was there any particular argument that you remember moving you in that direction where you went, oh, wow, this really is something I should think about, like, as a career trajectory or something I should try to move the needle on?
I don't know if I remember any particular writing piece. I think it was like a lot of prompts that got me thinking about the topic and, the stakes and why, that would be a very important thing to do. Yeah, it was just like the arguments made a lot of sense to me.
What do you think makes the stakes so high? Because I think everybody's got their own sort of internal story about that, and like what is important about intelligence, general intelligence, and so on. What do you think makes it the thing that you want to spend your career on?
Yeah, and I mean, if you think about this, right, in a way, what AGI is about is like the holy grail of AI research, or maybe even computer science research, or maybe research in general.
Yeah.
Right? Like you build a system or a machine that can do most or all things that humans can do, or that are economically valuable. And if you succeed at that, then that will change society quite substantially in various ways, and some of that can be really great, right? There's lots of things that nobody wants to do, and they're not that fun to do. And if a machine was to do that, then that would be great. And there's other things, that where it can cause a lot of problems, right? If you displace lots of people at their job and now they don't have an income, that's very problematic. And on the other hand, if we hand on more and more control and decision making to machines as a society, then those machines better make the decisions in a way that are aligned with our values, and that actually is what we want.
the specific way that you approach that is also kind of interesting, right? Because I think there are so many different schools of thought, not only on why the alignment problem is important, why AGI might be important, but also on like specifically how these problems should be tackled. Obviously, the alignment community is pretty big. There are a whole bunch of people working in silos and not silos and doing all kinds of different interesting stuff. One of the areas you've decided to focus on the most is the sort of idea of scalability of alignment solutions. And that's a theme that I've seen come up quite a few times in the context of your work and research. I'd love to get your insights on, so what does scalability mean to you in the context of AI alignment, and why is it so important?
Yeah, I mean, this is straightforward question, like story where just like, well, we expect, or I expect AI capabilities will keep advancing. And we've already seen a lot of scale, returns to scale in machine learning. And I expect we will continue to do so. But of course, like there's substantial uncertainty and disagreement on like how fast things will go. But I think the more kind of like interesting argument is that like this, in the future when we are at the point where like AI permeates society even more than it does today, the stakes regarding alignment are higher, right? This is what I was just trying to say, where like if there's like lots of automated decision making everywhere in society, like if the more that is the case, the more we would be invested in and care about that those decisions are made in an aligned way. And in order to, and that's like kind of like the problem that I care about. And so in order to kind of like prepare for this problem today, I'm particularly interested in scalable solutions in the sense that they will keep working for more capable systems so we can use them in the future.
And I imagine a devil's advocate position on this too would be like, well, if you think that that alignment will be important for capabilities in the future, if you think that people will just need to focus more on alignment in order to get value out of their AIs, then why prepare for this today? Why is it that we need to start working on scalable solutions today and not just sort of like allow capabilities and alignment to evolve together? Do you have any thoughts on that aspect?
I mean, in particular, you don't want to be in a spot where like, you worked on alignment for a while and then like, capabilities hit a point where like your solution stops working and you have to go back to the drawing board. But there's no guarantee that like, people will just stop pushing capabilities. And so then you're at the point where like the system is much more capable, but you can't align it yet. And that's the kind of thing that we want to avoid. And this is why we put such an emphasis on scalability.
Yeah, that makes sense. And I guess a lot of this too is also entangled with views about when AGI is likely to emerge. Like I imagine, for example, if you thought that we were likely only ever to hit AGI in like 100 years, you wouldn't be keen to place a long bet on like specific architectures or specific alignment solutions today, because like things will probably go in a completely different direction. Can you speak a little bit to that? Like, what are your thoughts on timelines to AGI development? And then how does that inform your thinking about which alignment solutions to emphasize?
Yeah, I don't really want to get too much into timelines because like, I think it's like a whole nother topic. But I think there's like a really good argument you can make here, which is like, what you could ask yourself, what if like it happens faster than we think?
Right.
And that's like, if you want to be prepared for that world, then you want to do alignment research in a way that can like deal with very aggressive timelines, even if you actually think those are pretty unlikely. Mm-hmm. And so kind of like, if you think about it this way, you want to be ready to deliver kind of like alignment solutions on a timeline that are actually where it's like actually pretty unlikely that it's actually necessary at that point. But of course, like we get more evidence about this as we go along, and we can kind of like adjust and hopefully adapt our strategy if it does actually end up going faster than we thought.
And so how does that affect the solutions that like you've chosen to emphasize? Like it sounds like you're definitely focused on, hedging against that risk, whatever the probability might be that we might hit AGI sooner than most people might expect. What kinds of decisions do you make as an alignment researcher, especially as a manager of alignment researchers, when you decide like, okay, we should therefore focus, if we want to hedge against this specific risk, we should focus on these strategies rather than these strategies, for example?
I mean, I don't think it's like I'm like hedging against specific risks, or it's not like we're placing a particularly high bet on like, you know, things working, like going particularly fast. But like the perspective that I'm coming from is kind of like the question of like, what if the current set of technologies will actually end up scaling up to something that looks a lot like AGI, and like how do we deal with that? So in particular, you know, like that means deep learning like continuing to scale, but it doesn't necessarily mean, you know, like I'm assuming like whatever we build in the future will be a transformer. Like maybe, but like maybe not. And I kind of want to have a solution, and like that's the general like the kind of like the scope of technical solutions that we're like working on right now is kind of like assuming that we have some kind of like deep learning model, although that's not necessarily a strong assumption. And but we're like pretty agnostic what exactly that would look like and how, you know, like what the latest hacks are for training it and so on.
Maybe this is a good segue into the specific like solution that you've been working on a lot, and reward modeling and then recursive reward modeling. So could you explain actually reward modeling just for starters, especially for people who are listening who might not be super familiar with like reinforcement learning? I think the idea of reward modeling and how it fits in that picture might be an interesting thing to explore.
Yeah, I would love to. Reward modeling is a really cool thing to talk about because it's like one of our staple techniques for doing alignment today. And I expect it will be a very important building block for like future alignment solutions. And if you think about reinforcement learning, right? Like in reinforcement learning, you have an agent that sequentially interacts with the environment. Like every time step, it takes an action. The environment returns an observation and a reward. And then, you know, like the agent is meant to like optimize its actions such that over the long run, like it gets good rewards or sums of rewards or average rewards or whatever criteria you want to give. And so one crucial assumption that is like typically made in reinforcement learning is that the reward signal is provided by the environment and it is the ground truth. So as long as you optimize that reward signal well, then, you know, the agent will solve the problem. And so this is true for a lot of the problems that the RL community has historically studied, right? So this is true like in Atari games, you can just look at how the score changes and like that's your reward signal. It's true in like StarCraft or Dota because you just run the game and you see who won and now like that's your reward. But there's lots of important problems where that is not true. So if you think about like, you know, what if you want to write, you want a system that writes you a fiction novel on the topic that you like. So now what is the reward signal here? There's like no, like the environment is making you like, you know, you punch keys on the keyboard. But then the reward has to be like you read the novel and you like it or not. But if you look at like how we train RL systems, it would take probably like millions or billions of like books it's generating until you actually find something you vaguely like. Yeah. And you're not going to be able to read all that. There's just no way. So what reward modeling is like basically a general purpose technique to solve problems that we don't have a procedural reward for. And the way it works is it's like very similar to reinforcement learning, but instead of having a reward signal that is coming from the environment, we get it from a human. And so in particular, we have like we have the agent just like generate a bunch of samples or like episodes or basically just like doing some stuff. And then the human looks at the stuff that the agent has done, and then they rank it or they label it like this was good stuff and this was bad stuff. And so that creates a data set, and then you just train a model on that data set, and the model predicts, you know, the model essentially understands what is it that the human wants. like what does good behavior look like? And important here is like the model doesn't or even have to understand how to get good behavior. So for example, let's say you want to train a simulated robot to do a backflip, right? Like I can't do a backflip.
Yeah.
I can't write a program that, does a nice backflip. But to understand what a backflip looks like is like easier in a sense than actually doing one. And so that's the task that the reward model does. The reward model understands the goal of what you want it to do. And then, then the RL agent is optimizing against that reward model. So the agent is trying to find, like behaviors that the reward model thinks are good, and then thus by proxy, you think are good. And like a very nice side effect of all this is that we can actually use this technique to train the agent to do stuff that we ourselves don't know how to do well, as long as we can tell whether the agent is doing a good job.
So would it be fair to say that essentially what this system does is it allows you to turn like a generation problem into a discrimination problem? Like instead of having to, be the generative model yourself, perform a backflip, you get to just be lazy and be like, that's a good backflip, that's not a good backflip, that type of thing.
That's right. That's exactly right. That's a good way of thinking about it.
Interesting. Okay, and so this, I guess one advantage I could see with this immediately is like it allows you to scale the amount of feedback that a human being can effectively give, and like you said, to comment or give feedback about things that otherwise you just couldn't give feedback about in an easy way, at least. This also tees up like your specific niche area of research that it seems actually really exciting. I've been super keen to dive into this one: recursive reward modeling. Can you explain, like, so where is the recursion? How does it play into reward modeling? What does it allow us to do?
Yeah, I would love to. So basically, if you think about like the class of problems that you can solve with reward modeling, right? These are the techniques we just discussed. These are problems where the human looks at what's going on and they say like, this is good or bad. But since we put this emphasis on scalability, we're particularly interested in what's going to happen after that. So eventually you're going to get to a point where now you want to train the system to do something that is actually pretty difficult for you to tell whether it's done well, right? So if you remember the example with like the fiction novel, you want the system to write a fiction novel that you like, but reading the entire book takes you a long time. So how do you train the system in this setting? The general idea, or like the core idea of recursive reward modeling is it's like very simple. It's like all we do is like we train machine learning models to help us evaluate the task. So in this case, like what is going to help you evaluate whether or not that was like a book you like? Well, you will have, let's say you have a model that summarizes the book for you, or like it summarizes the plot, or like you have a model that kind of describes the characters and the character development. Maybe you have a model that like can answer your questions about the book. And if you can just like imagine having a whole bunch of these like evaluation helpers, then you could leverage them to like quickly give some judgment of like whether this is going to be a good book that you like. So why is it called recursive reward modeling? So the key piece here is that because reward modeling is such a general purpose building block, we're just going to use it again. So for each of these systems, we like train them with recursive reward modeling, or just reward modeling, right? If it's an easy enough task, we just know how to do that task, you can just train it. And so for example, if you like, one of the evaluation subtasks is the task of like answering questions about the book, for example. And so what you do is you like just take that task, you train a separate model, and you're like, okay, so now I'm just training a model to get really good at answering questions about longer pieces of text. And if you compare that with the task that we started with, which is writing a whole fiction novel, this is now a way easier task.
Right.
And it's like it's also a more narrow task, because you don't have to think about like world building and complicated plots and characters. All you have to do is like answer factual questions.
Mm-hmm.
And so the general kind of like aim with recursive reward modeling, or like some of the hypotheses that it relies on, is that for a lot of kind of like valuable tasks that we want to train ML and models on, we can actually break down the evaluation of those tasks into simpler tasks. And that's like, or if you look at it from a different way, right? Like by training machine learning models on simpler tasks, we can then work our way up and train let them help us evaluate harder tasks, and then like solve those and work our way up from there. And like one really important aspect here is like you have a human in the loop in like every one of those tasks, right? Like the human always defines what it means to do well in the task, and that's like so that the resulting model is like aligned with them.
And would this be, because the human would be at the lowest level, right? The lowest level tasks, and then would basically train these evaluators, and then the evaluators, I guess, would evaluate the evaluators at the next level of the recursion. Is that
together with the human?
Together with the human. Okay.
So the evaluators help the human evaluate the next level task.
Okay, interesting. So the human is always part of every level of this process.
That's right. Like they give the value input, right?
Yeah.
They only know what the task, like what being aligned in the task really means.
I see. So at no point are you actually outsourcing like the responsibility of evaluating the task to another AI. It's kind of like, it's almost like these helpers are like doing some kind of dimensionality reduction on a super complex task and then presenting it to the human and being like, here you go, like this stupid human, you can understand this, is it good?
That's right. And like, or if you think about like the fiction novel that you like, right? There's no way for the AI system to really know what it is that you like on this day, right? And you have to say that. And like what we want the models to do is like we want them to help you communicate that most effectively.
And do you see this scaling up to like increasingly general systems? Like, can this go arbitrarily far, do you think?
I think there's probably going to be tasks that we can't solve with it. So one example I like to give is like writing a novel, like a book about a novel ethical theory is like something that would be very hard because there's like no way to like break down whether like the ethical insights are good without just like appealing to human intuition. And then like in the end, the human just has to look at it and like make a judgment, right? And I don't know if that's true for those particular examples, but there might be examples like that. But I think so. I guess like the ambition of this project is that for most economically valuable tasks, we can actually break it down in that way. Or actually more narrowly, that's not even what we need to aim for. I think what we like want to aim for is something that's more narrow, that I'm kind of like, that's more like an alignment MVP. And the alignment MVP is kind of, or the idea for alignment MVP is like, can you build a system that is, let's say, at least as good as at AI research as the best human AI researchers? It is also very aligned with human values. So if you have these two properties and you can like, you have very convincing evidence that these two properties hold, then you could, like have that system take over more and more of the AI research and alignment research work. And thus over time, like it will like carry much more of the load, and it will like solve like harder alignment problems for things that we like can't do with recursive reward modeling, or we don't really know how to approach.
Do you think like if there's a small misalignment, because I'd imagine there's always going to be some small amount of misalignment because you just have a limited density of feedback you can offer to the system. You can't tell it how you feel about every possible scenario. So there's always going to be like a little bit of misalignment in that system. I guess I guess what I'm wondering is like, does that misalignment get amplified as you use that system to build another more advanced system? Like, or does it, or maybe does it reduce? I have no idea what I'm talking about here, but maybe that's that's part of the challenge.
Yeah, I think this is actually one of the really key questions, and that's like one of the key questions that you want to study by building prototypes for these systems.
Mm.
And like in particular, I mean, as you say, right, like there's no way for the human to be in the loop on like every decision that's getting made. And like, but even more, you know, like if you train, let's say, a reward model to like replace the human at like giving oversight to the systems you're training, like the reward model isn't going to be perfect. Whenever you train a machine learning model, right, like it has a certain accuracy. And then like, you know, if you now picture like a recursive reward modeling tree where you have like some evaluation helper systems that are trained with this way, they have a certain accuracy, and then like they help you train another set of systems, and you just like build this, you know, giant tree. Like the situation that we don't want is that like at the root node, there's just like so much accumulated error that it's just not really that aligned anymore. Yeah. And so this is like one of the key challenges that we're trying to figure out how to deal with.
And like, how would you, I guess it's very early days for this, but I'm curious if you have any thoughts about how you would begin to explore that. I guess you'd need a way to measure degree of misalignment somehow, which is there a way to do that?
You can like do like approaches with the usual techniques that we have in machine learning, right? You can measure how like accurate each component is on what it's doing using like test sets and like, or, you know, more complicated things if you don't have an IID set up. But ultimately, you know, like I don't think we have a great theory of how to think about, you know, like how these errors propagate. And ultimately, I think, well, you know, the solution to this might look like fairly simple if you just like, you know, you have some kind of error correction mechanism that works across different levels of the tree. But this is like all, it might also be like very more difficult, or it might be that this is like what, you know, ends up breaking the system. But this is like very much an open research challenge, right? Like this is what we want to figure out how to do. And our approach is we want to build prototypes of these systems and then study them.
And do you build them at like small scale? Because I imagine you have GPT-3 available, and you'll continue to have larger and larger models, presumably. So would you imagine testing it on them, or would you start by testing it on, let's say, a smaller model that's maybe easier to work with? Or like, do you have a thought about that strategy yet?
Yeah, so I think it's like, it's not crazy to try this on like toy setting. In a way, the thing I'm most interested in is like try it on a setting that is somehow real, like in a way that like you're dealing with real data, you're dealing with real problem, and that way, you know, like you can be more sure that you're not just like sweeping some important problems under the rug.
Right.
And concretely, like, so one project that we're working on right now is on summarizing, on book summarization. So this is a project that actually started before I joined OpenAI even. But we are kind of at the stage where, you know, like we have a system that can summarize entire books, and not super well, to be clear, but you know, like it can do like an okay job. And the way the system works is kind of analogous to recursive reward modeling, but in a like more restricted sense. And so like the way the model works is just like we have the model summarize like a few pages at a time, and then you look at all of those summaries, and then you like have the model summarize a bunch of those summaries at a time, and you just like keep recursively summarizing until you have only one summary left, and that's your book summary. And so in this case, it's like simpler because we actually train the same model on like the entire tree, because like it's always the same task. You just like take a longer text and you make it into a text. But the interesting thing here, or like the analogy, is that you could think of this as, you know, like when the model writes a summary of the book, it would take a long time for the human to read the entire book and then tell you whether that was a good summary. But if the human gets to look at all of the
next
chapter
level
summaries,
right
yeah, the level below the chapter summaries, or it doesn't exactly correspond to the chapter summary, but like you can think of it like a way. So they look at the chapter summaries and then look at the overall summary, and that actually makes it like so much faster for them to like say, oh, okay, this was a good book summary. Of course, what you're assuming here is that the chapter summaries were good.
right.
And they're generally like, they're not very good. They're like, okay. And so there's like a limit of like how good you could even make that summary. But if you picture this like in the infinite limit, right, where we do really well at every part of the tree, then you would end up with you should end up with a pretty decent book summary. There's of course caveats to that as well.
It's still interesting though that you are taking such a hands-on approach, because I think these kinds of problems are, at least to my reading of like the alignment literature, there's a lot of stuff that's less experimental, that's less explicitly kind of tinkering with existing systems and trying to get them to do stuff, and somewhat more hand-wavy. And this is a theme I wanted to ask you about as well. Like, what's your view on that balance between experimentation and theory in the alignment community? I'm sure everybody has a different take on this, but I'm curious about almost your aesthetic preference. Should the community be focusing more on experiments than it currently is? What do you see as the value of theory going forward? Maybe what kind of theory research is most interesting to you, that sort of thing?
I think that's a really good question. I think there's like, I think the alignment community is pretty diverse, and people have like, they kind of like come at the problem with like a range of different tools. There's like, some people like, come from more a philosophical angle or a social science. Some people like want to address it with like formal math. And then there's like the more empirical research that, my team and I are doing. And I also like, I should be honest. I was like very firmly in the math camp for like when I started out. That was like back in 2014, because I just like didn't have a better plan of what to do. I think there's value in all of these approaches. I think like if you kind of like just look around on the internet of what people are doing, I'm a bit worried that like there is a lot of vague stuff that people are doing. And like, I think the problem with that is like, it's really hard to really build on vague things.
Yeah.
And I personally find that very difficult. And I think like as a kind of community, to make more progress, we have to move more towards the like, formal / empirical stuff. And then that makes it easier to build on.
Yeah, I remember, at least for me, one of the things that really struck me in this respect was a conversation that I saw on, I don't think it was the alignment forum, I think it was just like Less Wrong, but people were talking about wireheading. Hey everyone, Jeremy here. I just wanted to jump in and interrupt myself because I don't think wireheading is actually that widely understood of a concept outside of AI alignment research, and I figured I should probably add a quick explanation here. So wireheading is one way that alignment researchers worry advanced AI systems might fail to work as intended. The idea is that if we design an AI to optimize some reward metric, like points in a video game, for example, it might learn that rather than mastering the task we're actually trying to train it for, it can just tamper with its reward metric directly. So to take the video game example, a sufficiently general and capable AI that we're training to play a game might realize that it can just hack the game itself to make its score counter go up, potentially higher than it could even theoretically go according to the original rules of the game. Now, wireheading is a much more general concept than this, and it can take on far more diverse forms than I've just described. For example, a powerful AI that's charged with maintaining an optimal temperature in some office building could decide that manipulating the reading on its thermometer is easier than dynamically heating or cooling rooms. The bottom line is that wireheading is likely to be an important class of AI failures that have safety implications no one's quite figured out yet. One of the things that really struck me in this respect was a conversation that I saw on, I I don't think it was the alignment form. I think it was just like less wrong, but people were talking about wireheading. And there were, I guess in the context of that post, like there were a whole bunch of different ways in which the system could fail that were sort of listed. And I found that that aesthetic comes up a fair bit actually in the alignment community, where people will like list a whole bunch of different problems that they could imagine happening. And this is like, I think this is actually quite useful to some degree, because it has revealed new problems where you go, oh wow, we should worry about this kind of behavior. But it almost seems like a theory that doesn't point to a common origin of all these problems, that can't point to like a latent source for these issues and then how to address that latent source. It almost feels like you're playing whack-a-mole with a whole bunch of different problems that pop up in different ways. Like, I guess first off, I'm curious if you agree with that, and second, whether you think the empirical approach has a good shot at sort of covering that base.
Yeah, I think it's a really good question, because it's the question of like, how do you know you're really making progress, right? And I think the wireheading problem, or like, some people call it reward tampering, is a really interesting example, because it's something that you can't really study empirically yet, because our systems are just not smart enough to do it.
Yeah.
And you could like make it really easy for them, and then like they would probably figure it out, but like that's not as interesting to study. Like the scenario where like reward tampering gets really interesting is like when the system is actually smarter than you, and that's just not the case yet. And so, absent of empirical experiments that you can run on that now, of course, you need to turn to more theoretical approaches. But my kind of like perspective on this is that like what we need to get to on that front is like be in a space where that work then informs the empirical experiments that we do once that is possible.
And actually, that scale question is an interesting one too, because like I guess there's some exclusivity to access to the kinds of large models that would allow us to experiment with, when we hit something like AGI, this sort of wireheading or whatever else. Like, what are your thoughts on access to these models for the purpose of like safety, like independent safety researchers? Obviously, there's a narrative that, oh no, like OpenAI and DeepMind and so on are going to monopolize all the compute resources. No one will have access. I mean, I don't think that's really in spirit what's going on here. I mean, there are practical questions around like big models, are just expensive. There's a natural kind of moat that gets formed through no fault of anyone's. But do you think that there are going to be good ways for people to explore kind of reaching beyond the scale that's immediately accessible to them, maybe using theory to bridge the gap or something like that?
I mean, this is a really good question. And it's like something that comes up and again, because like the size and the spending on machine learning projects have been like steadily increasing. And like the budgets of academia obviously don't grow exponentially with it.
Right.
And so like naturally, like that excludes some people from, like access to these things. I know OpenAI gives like API access to like academics and safety researchers. And, like we want to enable people to still study models, like state-of-the-art models. Obviously, like we can't just put it up on the internet because like we actually getting to the scale where, you could do harmful things with the model if you put stuff on the open internet, anyone can use it for anything. But I think also in a way this divide is going to get worse if systems and like ML training spending keeps growing. And in some ways, like I think this is the reason why it is like of great advantage if you can do alignment research at like one of the cutting edge labs, and like you can just be where the state of the art is and like work with it directly. On the other hand, I think also like there's lots of kind of aspects of the problem that you can study in like a much smaller setting, and that would be valuable to make progress on that as well. So I don't think it's going to be the case that like if you're just in academia or something that you won't be able to do anything.
You'll have to be a little bit more hacky. Yeah, and actually, maybe a shout out to Andy Jones is in order. We had him on the podcast a little earlier, and he was talking about essentially this idea of doing experiments at small scales that try to kind of project out, increasing the size of the system and saying, oh, okay, here's roughly where we think things would go. And OpenAI's work on scaling laws for language models and other kinds of scaling laws really does help people out in that respect, because you're able to just like draw straight lines and make inferences, that sort of thing.
Yeah, I think that's very cool. And I think that's like a really good point. I think like Andy Jones's work is also like a good example of that, where like he got us like a really clear kind of like story in this like smaller setting. And then I think like one thing to be cautious of though is like if you're looking at like a scaling law or a trend, right, and you did like some small experiments, there's like no guarantee that this trend is going to hold over like many orders of magnitude,
right?
But when you're looking at these scaling laws, then you need to start with a small setting, because that's where you can iterate quickly, and that's where it's like cheap to run lots of experiments. And this is what makes this methodology so powerful, because you get to run cheap experiments that tell you a lot about expensive experiments.
Yeah, and they tend to give safety researchers more reach than people who are focused more on capabilities as well in some ways, which I don't know, maybe I'm in the minority here, but I actually tend to think that the consolidation of compute is not the worst thing in the world, the consolidation of those resources from like a public safety standpoint, because I'm not sure I want to live in a world where like every individual person has access to their own GPT-3 or even GPT-2 seems fine, but like we're going to discover presumably a whole bunch of different malicious applications of these things that like might take us by surprise if we're not careful. Like, I don't know if you have a view on this. I mean, obviously OpenAI, one way or another, is going to end up doing what it is because economic forces push things in a certain direction. But like, is there an argument that it's actually better that there not be full kind of democratization of scale, democratization of these kinds of AIs?
Yeah, I mean, this is like a big kind of like dichotomy in a way. Like, on the one hand, like you want like democratization of the technology is good because it gives more people access. It applies more checks and balances to like the well-resourced actors, and it makes it easier for other people to catch up. And on the other hand, like it also gives bad actors access to powerful tools. And so how do you solve this problem? That's like kind of seems very difficult to me. And like you could draw, for example, an analogy, right? Like what if like refined uranium was like freely available, like to anyone? Like that would probably cause a lot of problems. But I think this analogy is flawed because like refined uranium is like not a very dual use thing, right? Like arguably you could like use it to generate like power, but nobody's going to do that in their backyard. That's just like not really feasible. And so it's not actually, like going to give people a big benefit of having like free access to uranium. But the story is very different with AI, because if like AI is like a very kind of like general purpose technology that is just going to like help like so many aspects of your life. And so kind of like restricting that kind of technology is also very like in a way problematic, right?
Yeah.
So how do we solve that problem? I don't know.
Yeah, well, no, I totally agree, because it's also this really fuzzy barrier too, where I guess what we'd love to do is figure out this very nuanced decision surface where we're like, these people can access this kind of AI and then these people. But at the end of the day, that relies on our ability to kind of extrapolate and guess what sorts of malicious uses like people could put these things to. And my guess is we're going to be surprised. Like people talk a lot about, if GPT-3 were widely available, maybe you'd have OpenAI's published a lot of stuff about this too, like influence operations with elections, or you might have phishing attacks, that sort of thing. I'm sure there are other things too that a really creative like cabal of criminal minds could come up with, but like it's so hard to just think about that because there's limited time and you're just focused on building the capabilities of more systems, right?
and also like the tech moves forward very quickly, and
Right.
like often we don't really know in advance what it's going to be used for, right? Or what it
Yeah.
could be used for.
And I guess interactions between technologies too, because like, GPT-3 on its own today, not a big deal, but then you couple it to, I don't even know what you might couple it to, but deep fakes plus something else, and pretty soon you have like this high dimensional space of the different technologies that can do more things. And I guess the one other reason that I'm kind of like, I favor not having this kind of broadly distributed stuff is just that you might not necessarily be able to trust everyone to value alignment as much as other people. So like you're at the mercy at that stage, presumably, of like the person who can't be bothered to implement whatever alignment solution is like the order of the day.
Yeah, maybe the big question here is like let's say even we decided as a society of like, and we like all agreed of like which cases are like misuse of AI and which cases are like safety hazards or like misalignment hazards. And is there some way to implement a solution to that thing that like kind of like can enforce that for everyone while also giving them access to the underlying technology?
Right. Which I guess is kind of the trade-off that OpenAI struck with kind of GPT-3 access and monitoring what companies are doing with it, which seems like the best. I mean, I don't know. I'm not going to come up with anything better than that.
That's what we're like trying to do, right? Like we have the API, we can monitor what's going on with the API. We can like align the model. So one of the projects that the team is doing right now is we are making a more aligned version of GPT-3.
Oh,
and
interesting.
So if you think about how GPT-3 is trained, it's trained to mimic what happens on the internet. Yeah. So if you put yourself into like GPT-3's shoes, it's just like there's some random text coming your way. It's just like some web page, and you're just like making lots of bets of like what is going to be the next word on this web page. And so if let's say you want the model to write a story, or let's say explain the moon landing to a 6-year-old, right? So you say, please explain the moon landing to a 6-year-old. And what GPT-3 thinks is like, okay, what would come next on a website where that's written? Well, maybe it's going to be something like, please explain the immune system to a 6-year-old. And then it will just like generate prompts like that because it thinks that's most likely what's going to come next. But it's not at all what you wanted it to do, right? But the point is like, and this is what like alignment is all about. It's not, GPT-3 is not trying to do what you want it to do. It's trying to predict text in a web page. And so what we are trying to do is we want to train it so that it actually wants to follow instructions, and it's trying to like act in accordance with what you intended to do.
Is that because it seems like that would be a pretty fundamental shift in the training operation, right? Like, I mean, or at least the way I'm imagining it, you're sort of in training, it's trying to just predict the next token. How would you shift from that kind of framework to it's trying to actually do the thing that it's being asked to do, if that makes sense?
Yeah, we're not actually changing the GPT-3 training procedure. What we're doing is like we're taking the trained model and then we're fine-tuning it. So and this is like where we use reward modeling, right? Like remember that was like one of our staple kind of ingredients. So we use reward modeling, or at OpenAI we also call it reinforcement learning from human feedback, and we essentially like train it or we fine tune it to be good at following instructions and like making stuff up less and to like not say harmful things. And like if that goes well, then you'll have a model that is like both more useful and less harmful. And so the aim would be that we can like make that available on the API and people can use that. The team was working on before I joined. And this is like using all these same techniques. But there the goal was just to get like the model to summarize text. And that's like in a way like there it's getting aligned in a more narrow sense where like the task is to summarize just. And what we're trying to do with the like aligned or more aligned version of GPT-3 is like get it to follow your instructions And those could be like all kinds of instructions.
Okay, well, yeah, it's almost like we're already entering that uncanny valley where capabilities and alignment start to get more and more entangled, and it's hard to tell which part is which almost. I guess that's when we talked about there's sort of missing definition of alignment versus capabilities and like parsing those things out. Do you have a view on that? Like how should we think about these two things as different? What are the fundamental differences between capabilities and alignment?
Yeah, I think I think you're totally right. Like in many cases, it's actually very hard to fully disentangle those two things. Um, in the past, like a definition that I've used is like, how do we build agents that act in accordance with user intentions? But there, in that definition, right, like you kind of entangled capability
Yeah, yeah.
with it, right? It's just like if the system doesn't do what you want, like, well, it could be because it doesn't know how to, it's just not smart enough, or it could be because it just doesn't care about what you want, it just wants to do its own thing. Um, and like in a way, what you could say is like, if you just like want to specifically talk about that part, the like more alignment part of this, is you could say something. Well, does the model leverage all of its capability to act in accordance with your intention?
Mm,
But now you have this thing in there which is like, well, the model's capability. So how do you prove or disprove that the model has a certain
right.
capability? That's like an open research problem. And so it makes it in a way like more narrow and specific, but also like a lot harder to test. It's like a lot easier for me to see whether or not the model is doing what I want.
Okay, no, that makes sense. And actually, maybe a question too for any independent AI researchers, AI safety researchers, I should say, AI alignment researchers who are listening to this, because we do have quite a few. I've actually had some reach outs from folks who want me to ask questions like this more, and I think you're the perfect person to ask this to. What kind of research would you be excited to see people do, independent researchers? Like if there was an area for them to focus on that really matched kind of what you think is important, what would that be?
I think it depends a lot on like individual people's skill set and their like comparative advantage. So it's like very hard to give like a catch-all thing of like, here's something I would love to do see more of. Um, I think in general, what I like my experience is that people end up being most successful if they focus on like building their skills, joining an existing team, and then working collaboratively with other people. It's just like, you can tackle much bigger projects if you are acting as a team compared to acting individually. And like in terms of like building skills, right? Like the skills that we are looking at for particularly are like, do you have like ML expertise? Can you code? Can you like implement models and iterate on like research experiments? And like one of the classical ways to get that is like get a master's degree in machine learning or like a PhD or something. But that's not like, we don't require that, right? Like the question is like, you know, can you be productive on like our way of approaching alignment? And that's what we're looking for.
Do you see machine learning becoming more and more of a software engineering problem? Like as you scale models more and more, I mean, I imagine the focus increasingly is on like how do we parallelize better, how do we scale just the compute side better. This is going to obviously, I imagine, will have an impact, or there's going to be an impact on the safety side, the alignment researcher side, where alignment researchers are presumably going to have to get better and better at this stuff too. Is that fair to say? And if so, do you think that that's a skill set that I don't know how people could actually develop it independently, but is that something that people should start to think about?
Yeah, I mean, maybe the observation is a little bit that, as we get closer to AGI, it's probably going to look more like an engineering problem and less like a
Right.
science problem. Because, like, you're going to end up solving the science problems. And then, like, at some point, it's just like, well, now we need to build it. We basically know it's going to work. Or, and that's like, well, that's like highly abstracted, right? Like, realistically, it's like a continuum. Um,
Yeah.
but I think specifically for the approach that we are taking, it's like very engineering heavy, right? There's like some amount of time you spend thinking about like what is the experiments they want to run, or like what is like the problem I'm trying to solve. And then you just like write a lot of code and like get the thing to work. And then you have like all the experiences that you have when you're engineering deep learning systems, right? It's hard to debug. It's like, it takes a while to make it work. There's like so lots of subtle bugs everywhere. And that ends up like, just taking a lot of effort. But that's like, it's like a very tractable way to make progress, I think.
Are you generally optimistic about the prospects of resolving the alignment problem? I'm not saying solving, because I think probably some amount of misalignment is going to persist, at least based on our conversation so far. That seems to be likely. But resolving it to the point where we can set up this, as you say, AGI MVP. Do you think that's something that's more likely than not to happen?
I mean, I'm pretty optimistic about this direction. This is why I'm working on it, right? Like, I think, I'm like very excited about our current plan. And like, if I think back, right, like when I joined this field, like, 8-ish years ago, there was no plan. Like nobody had a plan.
Yeah.
Everyone was confused. And I feel like now we have a plan that I feel very excited about. And I want to see where this leads us. I think, overall, solving the alignment problem is not going to be the only challenge that we're going to have to face as we, as a society, transition into a post-AGI world. And there's like lots of other questions around like, governance and policy, some of which we touched upon. And some of them might be even harder than alignment, right? Like if you need to coordinate across a whole bunch of actors not to do a thing, that might end up being very difficult. I don't think anyone really knows how to solve these problems.
Well, maybe AGI can help.
Hopefully AGI can help, but
I mean, like the AGI MVP idea, right? Like that extends pretty nicely to AI policy as well, hopefully at least, where, we can actually solve some coordination problems. Maybe, I mean, who knows? It seems like it requires a lot of baseline trust too between countries and stuff that may or may not exist today. But
there's also like, to solve these problems, you might need like a very different expertise than you need to just do AI and alignment research. Hopefully, and this is kind of like the aim is, right? Like you could use something like an alignment MVP to get really good at AI and alignment research, and then build a better system that has broader expertise and can also help you solve these societal questions.
That'd be the dream. And actually, do the policy folks at OpenAI work with the like how closely are the safety and policy and like capabilities teams working?
Yeah, we talk to them all the time, and whenever there's overlap in what we're trying to do. So concretely, right, with instruction following project where we make this more aligned version of GPT-3, we have to then kind of like actually define what it means for the language model to produce a harmful output, right?
Right.
And that's like a pretty difficult question if you actually try to do it. There's like some obvious things, right? Like you shouldn't say anything racist. Pretty obvious, pretty easy. But like one is like, you quickly get into the nuances on like one is something, like creative freedom if you're like writing a fiction piece, and when is something like, false information, or like what actually constitutes as harmful, and like how do you make sure that you have a input from a diverse set of people, or people with like diverse backgrounds, because what's harmful to one person might not be harmful to another. And so no, those are all like questions that are like very like policy relevant, where the policy team has a lot of expertise. And so on these sort of questions, we're working quite closely with them.
Yeah, you can almost see the philosophy unfolding in real time. Like, can GPT-3 commit incitement? Can it tell somebody like, hey, go rob a grocery store or something, and they go?
Yeah, obviously you shouldn't do that, right?
Yeah, exactly.
But like you have to now think about all of these cases, and like, right, because when you use reward modeling, right, like what actually happens is like there's somebody sitting in front of the computer that actually has to rank, what is like better than what other thing.
Right.
And so they have to know how to make, what they have to label as like not okay and okay. And if you don't have like clear, if you haven't thought about like what exactly you want here, then how is that going to work? And that actually like leads to a much bigger and even more important question, which is, let's say we solve the technical alignment problem and we have like all the technical tools needed to align a system or like arbitrarily powerful AGI, say, to anyone. Who do we align to?
Right. Yeah.
And like obviously, like it shouldn't just be like whoever like we at OpenAI think should be aligned to. But like what would be like a reliable and fair process by which we determine like which values get installed into the system, and how do we like how do you, I don't know how to do that. I wish like somebody
Yeah.
figured it out.
Well, it kind of feels like there's a way in which all these things almost reduce to like the problems that humans have been trying to solve for the last like 10,000 years, where we don't really like subjective relativism is like this attempt to kind of bridge all this stuff together, but it feels like that's deeply unhelpful when it comes to a situation where, like you said, like somebody actually does have to give these commands. The symmetry is going to get broken between all these different moral frameworks somehow, and like that's a lot of power for one person or a group of people to have. It's cool that OpenAI is thinking this way. I mean, I think it's very fortunate that the people who are pushing in this direction at least have that in mind, because I could easily imagine us living in a universe where that is not the case and it's a full steam ahead focus on capabilities and just, I mean, that obviously wouldn't turn out too well.
And I think also like one way you could think about this is like you're kind of doing ethics research on a deadline, because usually if you want to find the like best people to get input into these things, is like people who have thought very deeply about like ethical questions. But they are going to tell you that these questions are very hard and they don't have the best answers. But like, if we actually end up building these systems, and that's what like, OpenAI and other companies are trying to do, like we're going to arrive at the point where we actually have to make a pragmatic decision of like, okay, what do we do now? And so that's going to be like the deadline by which we have to deliver, like maybe not like, what is the correct answer to ethics, but like what is like a good process by which we can determine the values that we put into the machine.
It seems to be a sense in which people who are wise tend to disproportionately discount their own knowledge and experience, kind of the Dunning-Kruger effect in a way. But like generally, there's an awareness that I'm smart enough to know that like the things I'm grappling with are really complex and really, really uncertain. Would there be a way to like formalize that in the actual approach taken by an AI system itself, such that it makes a call and the call could be wrong, but there's some sense in which it understands that? I know this is, now we're getting into the hand wavy fuzzy alignment talk here, but
yeah, I mean that would be good. I mean, ultimately, like as a society, we make ethical decisions all the time, and we have processes to do that. But also, like, yeah, on the other hand, as you say, right, you would hope that by the time we get there, we can actually leverage our AI systems to make that whole process better, right? Like, and there could be solutions that we can't really, like you couldn't do today, right? Like, for example, what if you have, like a system that everyone can talk to and just explain their values to them, or like the system asks like everyone in the world lots of questions, and then kind of like distills what the values should look like or would look like. I don't know how like building such a system would actually work. And there's like, lots of things you have to watch out for here. But like,
it's interesting.
All I'm trying to say is there might be room for like entirely novel approaches to this that weren't feasible.
Yeah, no, absolutely. I think that's a really interesting observation. It's like it opens the question of like how much of ethics is a data collection problem versus how much of it is like an actual reward function kind of alignment problem. And it sort of seems like, yeah, I could easily imagine there being a small handful of capabilities you gain just from the scalability of effectively glorified surveys via AI that all of a sudden make a lot, big families of semi solutions and patches work really well. And that could be an exciting avenue too. I want to make sure I remember to ask you this because I know OpenAI is hiring. We have people who are listening who I'm sure would love to throw their hat in the ring. Can you speak a little bit to some of the roles that you're hiring for on the safety team?
Yeah, we would love to hire more talented people. We are specifically looking for research engineers. So research engineers are people who like kind of like have both feet, like one foot in like research and one foot in engineering, and work day to day with models. We also hiring researchers. So in particular, if you have done a lot of work, publishing in alignment research, or even if you haven't done any alignment research before, but let's say you have a lot of research experience on like related topics in like natural language processing or RL in particular, we'd love to hear from you. We are going to need a lot more, like talent to make sure that we can actually deliver on all of the like kind of cool ideas that I've been talking about.
Yeah, well, and the stakes are high and the work is fascinating. So thanks so much for sharing all that information and all your perspective on all these issues. Really a fun, wide-ranging conversation. Really appreciate it, Jan.
Thank you so much for having me. It was great.